question 10, we have an arithmetic progression where the sum of the first 10 terms is equal to the sum of the next 5 terms. We have to show that the common difference of the progression is 1 upon 3a. So we know that the sum of the first 10 terms is equal to the sum of the next 5 terms. So that will become the sum of 15 terms minus the sum of the first 10 terms. The formula for sum of arithmetic progression is n upon 2 into 2a plus n minus 1 into d. So n is 10 in this case, so this will become 9d is equals to the sum of the first 15 terms would be, so over here we can also substitute 10 over here. For sum of the first 15 terms, we have 15 upon 2 into 2a plus 14d minus the sum of the 10 terms again, which is 10 upon 2 into 2a plus 9d. So taking this on the other side, we will have 5 into 2a plus 9d plus 5 into 2a plus 9d is equals to 30a plus 15 times 14 is 210 d upon 2. So this will, simplifying this will become 10a plus 45d plus 10a plus 45d. Dividing this whole equation by 2, we'll get 15a plus 105d. 10a plus 10a is 20a. 45 plus 45 will make it 90d is equals to 15a plus 105d. Taking the 15a on the left hand side, we have 20a minus 15a, which will become 5a, and 105d minus 90d would become 15d. So a is equals to 1 upon 3d. So a is equals to 3d, which will mean d is equals to 1/3 of a. As asked in the question, we have to show that the common difference is 1 upon 3a, so d will be written as 1 upon 3a. In part 2, it says, given that the 10th term is 36 more than the 4th term, we have to find the value of a. So for the nth term of an AP, we use the formula a plus n minus 1 into d. So a is unknown, n minus 1 will become 9d. For the 4th term, we will have a plus n minus 1, which is 3 into d. Now we know that d is equals to 1/3 of a, so we can write the 10th term is 36 more, so we can first make an equation where it says that the 10th term is equals to the 4th term plus 36. The 10th term is a plus 9d, and in place of d, we can substitute 1 upon 3a, and the 4th term is a plus 3d, so again we can write a plus 3 into 1 upon 3a plus 36. So this will become a plus 3a is equals to a plus 36. So 4a minus 2a will be 2a is equals to 36, which will give us as a is equals to 18. In part B, the sum to infinity of a geometric progression is 9 times the sum of the first 4 terms. So we can write that the sum to infinity is equals to 9 times the sum of the first 4 terms. We know that the formula for sum to infinity is a upon 1 minus r, and the formula for sum of a geometric progression is a into 1 minus r to the power n upon 1 minus r. The first term is 12, so we can write a is equals to 12 upon 1 minus r is equals to 9 into 12 into 1 minus, now this is we are finding the sum of the first 4 terms, so this will become 1 minus r to the power 4 upon 1 minus r. So 1 minus r and 1 minus r will cancel. So this 12 will cancel with this 12. So we have 1 is equals to 9 into 1 minus r to the power 4. Expanding this, we get 9 minus 9r to the power 4. So we have, if we take 9r to the power 4 on the left hand side, we have 9r to the power 4 is equals to 9 minus 1, which is 8. So r to the power 4 is equals to 8 upon 9. Now in the question it says we have to find the value of the fifth term. So for the fifth term, the formula would be a r to the power 5 minus 1, which is a r to the power 4. We already have r to the power 4 as 8 upon 9, and r to the power 4 is 8 upon 9, and the value of a is 12. So 12 times 8 upon 9 will give us the fifth term, which will become 32 upon 3, or 10 wholes 2 upon 3.